Hi everyone. Before we continue our VMD tutorials, I want you to know the difference between two important files types, the PDB files and the DCD files. So, as you know, PDB files are protein data bank, and these are the standard textual file format that describe the three-dimensional structure of molecules. Nice definition, but let's understand together what does it mean. So, you know that we get our PDB files from protein data bank or different databases. So who uploaded there? Scientists, of course, crystallization people, the people who try to get a photo of the protein, snapshot, protein or another structure. So they use different crystallization method to take a snapshot of the protein. So they end up with different data or coordination data for each atom in the structure, and they save it in a text file and they upload it into different databases, and the most famous is the protein data bank, and we go there and get it and start our different calculations or simulations. So the idea is like you take a photo for this guy while playing tennis, so this is crystal structure PDB file, just one frame. Later you go to a molecular dynamic simulations tools like NIMD or GROMACS, and you load your structure and different parameter files and force fields and whatever you need for the simulation, and you start your simulation. So your protein will start moving in different ways or based on time. For example, each specific period of time the protein is going to have different coordinations, exactly like this guy. Say this is the first nanosecond. Nanosecond is too big for simulation, but let's keep it nanosecond. At the first nanosecond, here's second nanosecond, and third, fourth, fifth, etc. So in each frame, you get different coordinations and also different energy levels. But now we are concerned with the coordinations, and when you combine them together, you end up with a DCD file, a trajectory file. A typical definition, let's read it together. It's a large binary file that contains the time-varying atomic coordinates for the system, as we explained. In each 1 nanosecond, the coordination will change. Each set of coordinates correspond to one frame time. Here, this corresponds to 0 nanosecond. Here, it corresponds to 2 nanoseconds or 1 nanosecond, etc. So we end up with a larger file, usually larger files, with extensions as DCD. So why this file is important? Because you're going to take this file and load it into VMD and study the protein structure at different times. At 0, how was the energy? At the last frame, after 100 nanoseconds, how was the energy? How was the salt bridge? How was the distance between active site residues? How was the secondary structure here, and how was the secondary structure here, etc. And that's why DCD files are important. So again, PDB file is a snapshot, just one shot, one frame, and DCD file it's a kind of movie, and when you're going to load it into VMD, you're going to see it's shaking or moving in a nice way. That's it, and thank you. And if you want to know more about PDB or DCD, you can learn. There are a lot of nice information about it, but I'm trying to make the videos as short as possible. Thank you.